Hey everybody. Okay, so today's video should be quite a bit shorter than the last few videos I've been doing. We actually only have one topic to go over, and it's the algorithm for dividing fractions. And it's not too terribly difficult, I don't think. And one reason I'm having this be a little bit shorter is because of the mind maps that need to also be done this week. So I'm give you a little bit of time to work on your mind maps and have the video be a little shorter and the homework that corresponds to the video to be a little bit shorter. So you should have plenty of time to work on those mind maps. Okay, so the topic for today is dividing fractions. And we're going to be using the algorithm. Okay, so if I look at a problem like this, so you might look at this problem and go, dude, what are you doing? You're losing it. You said dividing fractions. This is not division. I agree, it's not. But the way that I do this is very, very similar to how I would do my dividing fractions. There's just one extra step for dividing fractions. So what if we were going to do this problem, what we would do is we'd say, okay, well, this can be broken up into 3 times 5. I'm looking for factors that are in common, right? So you see that I have a 3 and a 3, that's good. And then here I see I have a 2 and 2 and a 5, and here I have a 2 and an 11. Or I could have done the 2 and the 6 and gone 2 and a 3. It doesn't really matter which one I use, right? So then I say, okay, well then now let's see if I can find my 1. So here's a funky 1 right there, and here's a funky 1 right there. And then I look at my 5s, and well, I can't do those because they're both numerators. So then I'm done. So then I'm going to multiply 5 times 5 is 25, and 11 times 6 is 66. And that's already simplified, so that's my answer. If it was an improper fraction, then I would, of course, do my upwards division to do it. So that's how we multiply fractions. So dividing fractions is very, very similar. If you think about how we did integers, adding and subtracting integers. So for the algorithms for adding integers, we did that little diagram that my student made up, but that didn't work for subtraction. So in order to do subtraction, we had to do one thing, turn it into addition, and then we could go back and do the algorithm we already knew. That's very similar to dividing fractions. So for dividing fractions, if I have a problem like this, okay, so a problem like this, then I can't break these up into their parts, to their factors, and then start simplifying, because that only works for multiplication. So instead, I'm going to use a very similar technique to something we've done before. It's going to sound very familiar anyway. So it's keep, change, flip. What we did for integers was keep, change, change. And that's how we were able to then use our algorithm for addition. Here, we're keep, change, flip. So I'm going to keep the first number the same. I change the second, or I change the middle symbol to the opposite of what it is. This is division. The opposite of division is multiplication. And then I flip this, or invert this one over. So my new problem then would be 8 over 15 times 30 over 10. Okay, 8 over 15 times 30 over 10. And then I go back and do exactly what I did before. So I say, okay, well, 15, I like that, 15 and 30. So that's 2 times 15. That's pretty cool. And then here I've got 2 times 4, and here I've got 2 times 5. So now I look to simplify, and I see these big old 15s are going to simplify out. These tiny little 2s are going to simplify out. It looks like that's all I've got. So now I've got 4 times 2, which is 8, and 1 times 5, which is 5. And then I can use my upwards division to simplify that. So I get 1 3/5 for my final answer. And I do want to put my final answer in simplified form. So if I need to make a mixed number, I'm going to do that. Okay, so that's pretty much it. If you can do multiplication of fractions, or if your students can, then division is not that much more difficult. We're just going to keep, change, flip it, and then we're going to do the algorithm to solve. So it's not too bad. So they can, of course, get a little bit harder than that. Let's take a look at another one. Okay, so what if they look like this? Okay, so 3 3/5 divided by 1 2/10. So not this particular problem, but it's possible that you might think, oh, I could simplify it. Let's say if this was 2/5. I'm going to change it back in just a second, but this will make a better example here. Let's say this was 2/5. So you say, oh, I'm going to simplify the 2 and the 10, right? No, you can't do that. You don't want to do that until you keep, change, flip. So you're going to leave these numbers just the way they are. It's not a terrible idea to simplify this one if you wanted to. You can totally do that. But you don't want to simplify anything here and here, because that's not really going to end up being a denominator. It's going to end up being a numerator. So I'm not going to do anything. I don't have my students simplify that or anything until after I've done my keep, change, flip. So I do my keep, change, flip. Actually, don't listen to me. I don't know what I'm talking about. The very first thing I'm going to do on this problem is I'm going to do the backwards C, because in order to do keep, change, flip, I have to have a single fraction. I can't have a mixed number. So the very first thing on here, I have to do the backwards C. So the only time I do the backwards C is for multiplication and division of fractions. I never do it for addition or subtraction. So 5 times 3 is 15, plus 3 is 18 over 5. And that's still divided by, and then 10 times 1 is 10, plus 2 is 12 over 10, all right? So 18 over 5 divided by 12 over 10. So now I can go ahead and do my keep, change, flip. And so I'm going to keep the first one the same. So 18 over 5, and I'm going to multiply this one. I change the division to multiplication. And then this one's going to flip over to be 10 over 12. Okay, so I have 18/5 did not change. My division symbol became multiplication. I changed it, and then I flipped this one over 12/10 over to 10/12. And now I do the same thing I've been doing for a while. So I see that this is going to be pretty cool. 2 times 5. And I see 6's going to both of those. So this is 3 times 6. And this is 2 times 6, like that. And now I can find my 1. So there's a 1 right there. And there's a 1 right there. And then I notice also that I have 2's. That works out. So those 2's simplify out. So on top I have 3 times 1 times 1 times 1. So that's 3. On the bottom I have 1 times 1 times 1. So that's 1. So my answer is just going to be 3. So 3 3/5 divided by 1 2/10 is equal to 3. Okay, so that's pretty much it. That's as hard as they can get. If you have only one of these that's a mixed number, either one of those, you always want to change your mixed number first into an improper fraction. So do the backwards C. Then you're going to keep, change, flip. Then you're going to do your multiplication skills, which is to simplify first. Okay. Okay, so that's the video for today. Like I said, it's going to be a short video compared to the ones we've been doing, but mainly because I want to give you plenty of time to work on those mind maps. Mind maps will include everything up till today's lesson. So this division fractions does not need to go into your mind maps. Only last week's will be the last topics that go in the mind map. So up to week 11 in the Canvas shell. Okay. All right. Have a great couple of days, and I'll talk at you on in a couple more days. All right. Bye bye.